So we ended with the Cambrian period, and now we're going to move into the Ordovician period. And each of these periods, again, they're generally earmarked for some significant change. And in this case, it would be the invasion of land. So we have our first land plants. We have what are called non-vascular. They do not have xylem and phloem. It's kind of like saying they don't have a circulatory system. They don't have a way of moving materials around their body very efficiently. And because of this, they have to stay very, very small. They also lack seeds. They reproduce by spores, and spores require water. So this is these types of plants would be what we call today our bryophytes. So ferns or mosses. And notice ferns and mosses are all in areas that have high humidity, and they don't get very big. So here's a little plant evolution. So here we started off with our ancestral green alga. Again, in order to go to land, they had to form what's called a cuticle that prevent that, I'm going to say desiccation or drying out. So they have to be able to not lose water. So we have our first group, and again, these were non-vascular. They don't have xylem and phloem. And so we have our mosses. Now eventually we get into our vascular plants. Again, here's our ferns. And then if we look at this evolution, I am going to put a different color here because it's not really clear, but at this point right here, okay, all of these guys over here reproduce by spores. All right, so we have non-vascular, and now we're going to get more complex. We're going to actually get a vascular system. That's our ferns, but they still use spores. And then we're going to evolve the point where we now have seeds. And there's different types of seeds. And in the movie, we saw that seed floating in the air and being able to withstand long periods of time before they actually grow. So in that same time period, we're going to have our invertebrates with our jointed appendages and our exoskeletons. And they're going to, these adaptations are going to allow these organisms to leave the water and go up on land, and this is what's going to give us our insects. Now with our vertebrates, those are organisms that have a true backbone. We're going to begin with jawless fish. And again, these are aquatic, so in the water. They're cold-blooded, they have gills and scales, and this period will end with a mass extinction, and we'll go into the mass extinctions at the end of this chapter. So in this picture, you can see some of the organisms that took place in the Ordovician period. We have this crinoid-looking object, which is probably more in our Cnidarian group, and then we have our segmented invertebrates here that would probably give rise to like our arthropods. Here's our jawless or a fish that will eventually looks like a relative of Tiktaalik, which will lead to amphibians. And then we have this guy here, which is more of like what we would call today like our cephalopods, our octopi, and squids. And we can see in this time period right here, we have the little cross where this mass extinction occurred and ended this time period. So again, periods are ended and began with some kind of significant change, whether that's a positive one or a negative, and in this case, of course, an extinction would be a negative one. So our next period is the Silurian period. In this we can see where our plants, we still have seedless plants, and they contain vascular tissue. So we're getting up to where we have the ferns. So we're up to ferns. They still reproduce by spores, but like we said, they have a vascular system. So our plants are able to get larger. So here are some sketches of the type of aquatic organisms we would see in the Silurian time period, and we get our first jawed fish. So we have fish now that actually have jaws. Now we're going to move to the Devonian period, which is 416 million years ago, and this is where our plants first appeared to reproduce by seeds. So this is the actual period where this occurred. We have invertebrates now that are adapted to live on land, so we kind of saw some of those again in the video that we've been watching. The Devonian period is often referred to as the age of the fish, and they were obviously the ocean was dominated by these type of organisms. We can see our continents in this picture with our two main parts, our Gondwana and Laurasia. And this is where we're going to start to see our first amphibians. So we've got our Ichthyostega. So where we here have something that's kind of like Tiktaalik right here, which will then end up with its limbs able to support its weight out of the water. It is suspected that was a way of avoiding predation from all those nasty predators in the water. And in order to do that, of course, they had to be able to gulp air or become air breathers. So they have what we call lobed lungs. So the development of a mechanism to take in oxygen without gills and being able to support their body up on land allowed them to utilize a habitat that was not previously able to be utilized by animals. Also, remember, with all the plants that we've been talking about, the ozone layer has helped to protect those organisms from the UV radiation. So when we talk about the Devonian animals, we're talking about giant predatory fish, cartilaginous and ray fin fish. This would be the ancestors of sharks. And like I had mentioned earlier, those lobed finfish could venture out of water and up to shore to lay eggs in inland pools, escape predation, and find food, insects. This period also ends with a mass extinction. Now we're going to enter the Carboniferous period, about 359 million years ago. And this is where we saw in the movie with all those plants, they were talking about the plankton and the fish dying, and of course it's going to fall to the bottom of the ocean. This is where much of the oil has come from. We also know that large amounts of plants that had died, that material will end up being the great coal-forming forests. So at this point, the seedless vascular plants flourished and pretty much dominated the land. And you can see here the picture of the two major continents here. And here we have a picture of what we think the land looked like at that time. You can see a ginormous here dragonfly. You can see some of the larger plants, a lot of the ferns and stuff that took place. These are, over here, these are called horsetails. We still do see those today. I actually saw quite a few of them out and around Glacier Park last year. So a lot of places around this area still support these type of plants. So some of the animals are in the Carboniferous periods. Of course, amphibians became very diverse. We first see reptiles that appear. Again, the major difference between amphibians and reptiles, if you look at an amphibian has skin versus a reptile has scales. This again allows it to move away from water. It's more efficient from losing that water. They also have developed a shell, a leathery shell around their eggs so that, again, they can leave water. They're not dependent on a water for reproduction and to stay hydrated. So some major adaptations that are different between amphibians and reptiles. We also call this the great radiation of insects. And I already kind of talked about this in that we saw this spiders and the centipedes and millipedes. They just, more and more diverse. At this point, we really don't have a whole lot of predators for these insects other than the amphibians and the reptiles, which are kind of limited to the ground. So a lot of different planet Earth look very different in this time period. So when we look at the Carboniferous, our age of our amphibians, again, the swamps provided water for forests and refuge for amphibians. Some amphibians adapted and formed scales, which protected them from predators and dehydration. Some amphibians actually lost their limbs to become the ancestors of snakes, and others developed the ability to eat plants. And again, we call this area the Carboniferous period because this is where we do get these fossils that form the coal and the oil that we have today. That is one of our main source of carbon that we use from these organisms dying and then being converted into coal and oil. You could say kind of like a metamorphic rock. So this ends this phase. The next presentation will pick up with the Permian period.